If you can divide that up with
All righty. So a little bit of review. We finished talking about correlation, right? We finished talking about correlation and how to interpret R. How do we know how to do that on the calculator? That's where we finished the first set of notes. And then we started with the second set of notes about this line of best fits. The line of best fit, the line that fits the data the best, right? Because we know the data looks something like this. For this problem, the data looks something like this. Okay. As miles driven gets further and further, increases, I should say, price of the car is going down. Okay. So, the correlation coefficient, or sorry, the linear regression line of best fit is a line that best fits that data. So if it was perfect world, all the dots would make one straight line and we wouldn't worry about it. Line of best fit would just be one line going like that. But as you can see, the dots don't line up like that. Okay. So we got a line of best fit. So every line has a slope and a y-intercept, right? So we came up with that. We had the calculator calculate our slope and our y-intercept. Okay, we're gonna do some more practice on that so you get used to it on the calculator. So we said the slope was negative 0.086. So we interpreted that by saying for every 1 mile driven, the price of the car is going to go down by about 9 cents, 8 or 9 cents. Okay, that's why it's got a negative. Okay, and then the y-intercept was 18,773.284. And the y-intercept is when x is 0. So when miles driven is 0, brand new, that's how much we predict. Now, is that how much the actual new car is? I don't know. It's a prediction based on the data, based on the data points. Okay. And then we put it all together and we put an equation together, right? So today we're going to use that equation. We're going to use it to predict. Okay. We're going to use it to predict price based on miles driven. Okay. Because the next slide says, okay, so predict what the value of a used CRV with 50,000 miles will be. Well, let's go to my list. Do I have a 50,000 mile car? Going pretty close, 49,000, right? And then 55,000 is a little over, pretty close, but not 50,000. So, but I can predict it. I can use my data points to predict what that would be. So what do you think I'm going to do? Because you guys probably already know. What are the steps I'm going to do? Yeah, just exactly. This is 50,000 miles, right? Plug it in right there. That'll give me the predicted miles. So we don't say y hat. Remember, we say predicted miles or predicted value. Sorry, predicted value. Equals, what was it, 18,773 and 284 and change minus 0.086 times miles driven. Well, in this case, it's going to be 50,000 miles. So I'm going to put a 50,000 here and crunch those numbers. That's the only work I need to see. That tells me exactly what you're doing. Calculator does the rest. So what operation am I going to do first? Am I going to do subtraction or multiplication? Well, yeah, distribute multiplication, right? distributive, which is the same as multiplication. So do multiplication and then subtract. Don't do subtraction first and then do multiplication. So when you do that, what do you get?
14,473.2.
473?
Yeah.
0.284?
Yeah.
We'll go 29 since it's dollars. Okay. Okay. Now the next thing is, does that make sense? Does it fit with the rest of our data points? Does it fit with that a $50,000 mile driven car is about $14,500? Well, let's check the one that was close to. It was very close to this guy, right? And that's pretty much identical. So yeah, it makes sense. Okay. The reason it's important is for the next one. Let's look at the next guy. So now we're going to use to predict for 250,000 mile car. Okay, 250,000 miles driven. How much would the predicted value be there?
It's a negative. Oh, no, there.
So 18,773.284 minus, except this boy right here is going to be big, 250,000, $250,000. Did you also get a negative number?
Yeah.
Yeah, it's going to be a negative number. It's going to be negative what? 2726, you said?
Yeah. 76.
How confident are you in that prediction? Not very. Not very. What does that mean? In real life, what does that mean if it's got a predicted value of negative? It means to take my car, I got to pay you that much money.
I gotta pay you.
Exactly.
It is so bad.
Right? Exactly. You have to pay them almost $3,000 just to take it off your hands. That's not realistic.
It could be.
Now, you might have to pay a little bit if no one wants it to get rid of it, but you're not going to have to pay $3,000. Okay. So I'm not very confident in it. Okay. This is an example of what we call extrapolation. Extrapolation. I'll explain what it means. Extra, and then polation. That's why you're not very confident in it, because it's an example of extrapolation. Extrapolation means taking one thing and going off the cliff with it, right? What is the range of miles driven on our list? From 22,000 to 86,000, right? Stops at 86. Now 200 goes way more than double that, right? So we're extrapolating outside the range of our data and not even close, right? That's not even 100,000. 100,000 would be extrapolation, but 200,000 just goes way past it. So we're extrapolating outside, right? If I had my graph here, 200,000 would be way down here. The dot would be way over here, right? That's way outside the range of the data points. Anytime you do that, it's called extrapolation, and it's not good because you're not going to be confident with your prediction. I did everything right. I did all the math correct. It's not like I did it wrong, but it's just so far outside of the range of my data, I'm not confident. Okay. Now, 50,000 I was pretty confident in, right? I was pretty confident in it. That's called interpolation. Interpolation is what we want. That means the data was within the range. 50,000 is within the range of the other cars that I have. Extrapolation, 250 is way outside the range. I'll give you a number, but I'm not confident at all that that number is actually going to be true, right? So I picked one that was extreme because it's a negative big number. So in real life, that means you have to pay someone almost $3,000 to take your car, right? When in real life, the car is either worth something or it's worth nothing. It can't be worth negative. Cars aren't worth negative, right? Even if they don't work, even if they don't run, they're worth something because they're worth parts. There are some parts that work. And especially like a Honda, Hondas are worth money because a lot of people have Hondas. Yeah, 250,000, they will go. If you treat your Honda right, it will go 250,000 miles plus. Yes, if you treat them right, they will. Okay, one of our, not a Honda, but one of our teachers, Mr. Facciani, teaches two doors down. He still has a Toyota, and he had over 300,000 miles on that car, and it was still running fine. But he, a few years ago, he sold it, and he got a new one. Okay, so because he said, why would I buy a different car when I can have a car that runs over 300,000 miles? Okay, so, but based on our data, there's nothing near 200,000 miles in miles driven. So that's why it's in extrapolation. I can only predict within my range. Anything outside of my range is too much prediction. Okay, so that's extrapolation and interpolation. Okay, so now what I want you to do. So I did this for, it wasn't last year, it wasn't 2 years ago. I think it was 3 years ago. I think it was the last year of normality that we had, because last year we were mostly on distance learning. The year before, school closed down in March, so we didn't even finish the year. So I think it was the year before that. My AP stats class was in 6 block. So I had them measure 2 things. I had them measure their shoe size, or just not measure their shoe size, but what was their shoe size. And then I had them measure their height. Okay. So men's shoe sizes versus women's shoe sizes. So if you're a male and you have size 11 shoe in male, in women's you would have 12.5. So you just add 1.5. And if you're a female and you want to get your male size, you would just subtract to 1.5. So I had everyone's just men's shoes. Okay, so what I want you to do is create a scatter plot. First thing we're going to do is create a scatter plot for this data here. Okay, use your calculator to create a scatter plot. This is real data. These are numbers that, like I said, students I actually had, I think about 2 or 3 years ago. And then right below it on your paper, you see that there's 5 questions. Do those 5 questions as well after you do your scatter plot. Okay, so sketched it. So it's got a positive, we see it's got a positive R, 0.777. Almost strong, more, but it does fit in the moderate. So interpret R, so moderate. Or it is kind of high, it is kind of close to 0.8. So if you want to put moderate to high, moderate to strong, that's okay. But I would include moderate. Moderate is what I would look for. But if you want to put moderate to strong, you're not lying, because it is close to strong. Okay, so moderate, positive, since the number is positive, linear relationship. Okay. I got A and B as well as R. A is 54.071, B is 1.462 using the calculator. Put them together. Your Y hat is your predicted height, because that was the Y. So we're trying to see if, based off your shoe size, can I predict your height? That was the question that we posed when I did this. Based off your shoe size, can I predict your height? How good of a predictor is shoe size for how tall someone is? Okay, so slope, 1.462, 1.462. So remember, it's change in Y over change in X. So for every one X, so for every one increase, or so X is, what was X shoe size?
Yeah.
So for every increase of one shoe size, Y is going to change by that number there. Height will increase by 1.462 inches. So based off our data, if your shoe size gets bigger by one size, your height will increase by almost 1.5 inches, based off our data. Okay. Y-intercept, any Y-intercept is when X is 0. That's the number. So when X is 0. So when shoe size is 0, exactly. So we'll talk about that. Let me just write it down, but we'll talk about the context. Yeah. When shoe size is 0, height will be 54.071 inches. Now, just like Aldrin said, what's the problem with that? Everyone has shoe size. No matter if you're a newborn baby or whatever, everyone has a shoe size, a type of shoe size, right? So shoe size can't be 0. So it has no, in context in real life, doesn't make sense. But it is what it is. Okay, sometimes it does make sense, right? The problem we did earlier, the problem we did with miles driven, it did make sense. 0 miles driven can't happen. It's a brand new car, right? But shoe size, it can't happen, right? So it has, you interpret it, but it has no practical meaning. Okay. Okay. Okay, so this is the graph. This is the graph that you guys just drew. Okay. So we know that the slope of the line of best fit or regression equation or least squares regression line has positive, right? It has a positive slope. Was it 1.46 something, 62, something like that? It looks something like that. Okay. So what I'm going to show you now is how to show that on the graph. Okay. So go back to your, let's look at. So what I want you to do is go to your scatter plot on your graph, on your calculator. Scatter plot on the calculator. Looks like that, right? Okay. So the line of best fit, we know what the line of best fit is. We just wrote down the equation here. Wrote down the equation here, right? So I'm going to show you how to show it on the calculator. Okay. So you remember when you went to go watch what I do, and then I'll let you do it. So remember when you went to go find A and B and R? You went to stat, you went to calc, and then you went down to lin reg A plus BX down here. And then you hit enter. And then you said, are the X values in L1 and the Y values in L2? Yes, you hit enter, and you kept hitting enter, and then you hit enter again. One of the enter is store linear regression. Store means the calculator remembers it. Okay, so when you calculate it, my calculator remembers it. Okay, so now when I want to graph a line, this is the only time we're going to use this function in this class. But normally when you graph on a graphing calculator, you use that Y equals button, right? The Y equals. So go to that Y equals. If there's anything there, hit clear. We don't want anything else on that graph. We don't want anything on here. We want it clean. So now what I'm going to do is I'm going to put my regression equation in there. My calculator remembers it because it said store. Anytime you find A or B, it remembers the equation. So what I'm going to do is I'm going to go find it. Okay. So where is it? Don't do this yet. I'm trying to remember where it's at. Haven't done this since last year. Let's see, where was it? Give me 1 second. Is it Vars? No. Distribution? No. Stat? No. Where was it? Oh, okay, I know where it is. Okay, so we're at y equals right now, right? Oops. We're at y equals. See this button that says Vars, V-A-R-S, right underneath by the clear button? You're going to click on that. Take you to this. You're going to scroll down to guess which one we're going to choose out of all these. There you go, statistics. So go down to statistics, hit enter. Okay. Some of these symbols look familiar. We're going to go over to where it says EQ, equation. Top one, regression equation. That's what we want. We're going to hit enter and see what happens. It remembered it. Because it remembered it, now it's going to graph it. So now what I want you to do is go back to your scatter plot, see what happens. Go back to your scatter plot and see what happened when I did that. So zoom, stat. Okay.
Oh, you don't have the one that is it's not upstairs. You just have to go to
Yeah, so anytime you use your calculator to find A, B, and R, it'll automatically store it. Okay. So if your calculator doesn't remember it, go back to find A, B, R. Okay. Okay, so now the line, what does the line represent? So what is this blue line? Okay, but what does it represent in terms of my question? The data we have. What does it represent? It's an estimate. Okay. Using the data that we have. So what kind of data do we have? What kind of data do we have here? Give me anything. What are these? No one knows what these numbers are?
these quantitative
No.
numbers.
Flores.
He's gonna say some fancy word.
Okay. So what kind of numbers are what are these? Thank you. They're shoe size and height. No, I'm like, what are they? They're just shoe sizes and heights, right? That's all they are. Right? They're not number thingies, right? All right. They're not number thingies. Try putting that on the test. See what happens then. They're shoe sizes and heights. Okay. Okay. So now that we have shoe sizes and heights, tell me, what does this dot represent? Or this dot, or this dot, or this dot, or this dot? What do the dots individually represent?
The actual data in the table.
Okay, I heard some others. A shoe size and a height for who? A person, okay? So if there's 31 people, there are 31 dots, right? Okay, so that's what each of the dots represent. Okay, so let's move on. What does the line represent then? If the dots represent a student, 31 dots, 31 students, their shoe size versus their height, what does the solid line represent? Not the average. Oops.
The perfect ratio.
So isn't a line just a bunch of dots all together? Exactly, right on top of each other. An infinite number of dots, right? So what if I had a dot? So let's see here, I got dots here. What does that dot represent? It's on the line. Doesn't represent a person. It's not a person because it's not one of the dots, right? The people are the dots. It's a predicted, right? It's not actual, it's predicted. If you want to know what actually happened, go to the dots, right? Some of the dots are on the line, like this dot right here, this dot right here, those are on the line. This dot right here, this dot's pretty close, but some of these dots aren't on the line. So they're not students. And what are they, Josh? They're predicted. It's what I predicted, right? So the line is a prediction. The dots are what actually happened, okay? And there's some distance in between them, right? There's some distance in between some of them. Some of them are right on the line. Some of them are a little bit off, right? There's distance here, distance in between. That distance is what we call a residual. Okay, so let's go back. Right here. It's called a residual. It's the difference between what we predicted and what actually happened, right? If we predicted correctly, all the dots would line up right on the line perfectly, beautifully, that would be it. But that's not real life. So the difference between what actually happened to what we predicted is called a residual, okay? So if we want to find the residual, we have to find the observed, what actually happened. Find out what we predicted would happen. Subtract them. That's a residual. Okay, that's a residual. So believe it or not, our best fit line will always miss most of the points, right? There was only about 3 points on our data here that hit that line perfectly, right? So now what we're going to do is, how do we find the residual value for a person who had a size 7? And that'll be my residual. So we need 2 things, right? To find the residual, we need 2 things. We need the actual and we need the predicted. The actual value, let me write it up here. Let me move it so I don't run out of. So we need the actual value minus the predicted value. All right, that's what it says. Yep. Okay. So how do I find the actual value of a person who has shoe size 7? Look at the data. So let's go find out. There we go, right? There's a couple different 7s. There's a couple different 7s on the graph. How many 7s are there? 2, 3. Let's pick the first one. 64. Let's pick the first one. The first person who had a size 7, height was 64. Okay. There's others, but we'll pick the first one. So what's the actual value? Yeah, it's not going to be 7. It's going to be what they were. So residual. What was their actual value again? Not 7. I already know that. It was 64. Okay. Yep. And then how do we find the predicted? Plug in 7 to our equation, just like we did earlier, right? So within here, I need to figure out, I need to get my equation again. Let's see, my equation was right there. I wrote it down earlier, 54.071 plus 1.6462 times the shoe size, right? Okay. So what do we get when we let me write that down. 54.071 plus 0.4 times shoe size. Well, what's our shoe size? What was our shoe size going to be for this one? 7. Okay. So we do that first because it's in brackets. Within the brackets, we do multiplication first. What's that? Oh, you got it? You've added it all up and everything? 64.298.
You get it? Please tell me I didn't do it wrong. With close?
Well, I know that I did mine earlier and it was accurate. And
I'll just do it again.
Okay. So when I subtract, what do I get? Negative 0.298.
Oh. Yeah.
305 at the end?
Yeah.
Okay. That's close. $305. So this is the residual. This is the residual for the person who had a shoe size of 7 and a height of 64. Now there were 2 other people, but we would do the same thing. The only thing that would change is their actual, right? Their actual would be different if they're different than 64. Okay. Negative residual. What does that mean if I have a negative residual?
Means you're below the estimate.
Means I'm below. My estimate was above. I predicted too high, right? I predicted too high. Which dots would those be on the graph? Are those the dots above the line or are those the dots below the line? Well, let's see it. What did I say again? I predicted too high, right? If I predicted too high, that means everything below. So if you're below the line, it's going to be a negative residual. So all of these dots below the line, these dots are going to have big negatives, right? Okay. The dots above it are going to have positive. And if it's right on the line, there is going to be no residual because there's no difference, right? All right. Okay. So what I want you to do now is, what's that?
So our pigments are below it.
Mm-hmm. So our residual for this one was just under, barely under. So it's one of these that are pretty close to the line. I don't know which one exactly because I don't have a number line or I don't have a, but it's one of those. Yeah. Okay. All right. So do the next one. What is the residual value for a person of shoe size 10.5? If there's 2 people that have 10.5, choose the first person. So there's only one 10.5. 10.5, 68. Okay, so that residual is negative as well. I predicted too high. This one's a little bit lower. Okay. Yeah, so we'll stop there. Yes, we'll stop there and we'll look at residual plots next time. Okay, so you know how to find a residual. That's what we'll pick up tomorrow. Pick up tomorrow with how to find a residual, because we're going to use them for something later. Okay.